right, in lesson 2, 7th graders, we're going to go back and talk about combining like terms. I say go back because in lesson 2-3, chapter 2, we were already learning about combining like terms. Okay? So let's talk about like terms for a minute. What does like terms, what does that even mean? What are like terms? How are they alike? And what are some that are not alike? How are they alike? Look at these terms. Which ones are alike?
Write this down.
Sure, helps. But make sure you're not just writing, but you're thinking. What are like terms? Brett?
Like the 2x and the 4x, they both have an x. So.
Okay, the 2x and the 4x are like, correct? So, what can we do with like terms? We can add them, right? We can add them. Now, we're talking about addition here. Combining is always talking about addition. Addition and subtraction, I should say. All right? Not multiplication. We're not talking about multiplication and division when we're talking about combining like terms. We're only talking about addition and subtraction. And that's right. We can combine these. We can add these two. What is 2x plus 4x? Jeremiah. 2x plus 4x.
6x.
6x. So we've simplified these terms to 6x. How about, can we add 5 to that?
No.
Can we add n to that?
No.
Why not? Carson?
We can add 1.
Well, that's not really adding.
No, you can't add.
We can, not the operation of adding or combining. This is 1n, yeah. But are these alike?
No.
No, they're not. No. What about, what if these are not in this order? What if this said 2x plus n plus 5 plus 4x? Then could we add them?
Yeah, well. Yep.
We could?
Yeah.
Sure?
Yes.
Yeah. Why? What is this?
All of them are adding.
Yeah, and what property is it that says you can change the numbers around, or the commutative property, right? So even if this 2x is way over on the left side and the 4x is way over on the right side, because of the commutative property, you know, you can switch the terms around as long as it's just adding, and we can combine these. Okay? Can you combine these?
Can
You can add all of them because negative n is 1, negative 1.
Okay, good. This is negative 1n. But how do we add the negatives? Does that just get rid of the n's? Like, is 4n plus negative n equal 4? Because we got rid of the n's? Max?
You would add negative 1n and negative 3n to negative 4n.
Okay, good. So we have negative 1n and negative 3n equals
Negative 4n.
negative 4n, and 4n plus negative 4n is it n?
No, it's 0.
It's 0, yeah. Because all of the n's are, these are opposites actually, okay? These are opposites. You can add 4n and negative 4n, you get 0. All right? Or if you think of it as 0 n's, what's 0 times n? 0. Any number times 0 is 0. That's how you end up with 0, Lydia. See that? All right. Open up your notes. You got your notes out? And your book. Open your book now to page 356. Page 356. We're just going to talk about combining terms first and then solving. We're just going to talk about example 1 today. So, here's example 1 from your book. In a model, each of these is a plus 1. So if you're drawing a model, you can write these as just pluses. Anytime they're blue or yellow, they're pluses. Anytime they're red, they're minuses. So all of these are just plus 1s. Now, we have on the left side, what do we have here? What are these two together? Jen?
2x.
2x. How many positive 1s do we have?
We have
Jen?
7.
7. And
1.
another x. And when we just have a group of them, they're all on one side, we can put plus signs in between. Okay? Got that written? No, that's here. Under here now, we're under here. Okay? Now, what's on this side? These are all the same as these. So this is 16. And the line equals its equal sign, positive 16. Now, when you're solving this equation, we have coefficients, we have numbers, and we have what it's equal to. So it's a lot like the ones we did yesterday, right? Except that there's something that we can do first before solving this, which will make it easier. What can we do first? Abby? Right, add the 2x plus the x. So we have 3x. And we still have the 7. And so we've simplified this side. We didn't move anything, we didn't change anything, we've just simplified it to make it easier to solve. That's what combining like terms is all about. Is simplifying it, making it easier to solve. Okay? Now what? Now how would we solve it? Daria?
We would add negative 7 to both sides.
Good. We have 0 and 16 plus negative 7 is 9. And we still have 3x plus 0. So this is 3x equals 9. And then we can either divide by 3 or multiply by its reciprocal, and we get x equals 3. Yep. X equals 3. Okay? So, it's all about, it's first combining like terms. Go to your assignment page, 359. And I'm going to show you why when you combine like terms, it's easier. if you have one like number 1, 8a plus 4a equals 144. How can we solve this more easily than?
You add the 8A and the 4.
Yeah. What do you get? 8a plus 4a is 12a equals 144. And then? Yep. Divide. Cross out the reciprocals. A equals 12. Yep. So, 12a, 12 times 12 is 144. Is 8 times 12 plus 4 times 12 also 144? 8 times 12 is?
That's 89.
Yep. 96 plus 12 times 4.
46.
Any questions? I want you to do 1 through 7. Page 359, 1 through 7 for tomorrow. 1 through 7.
Odds are
Good one, Roy.